Hey everyone, it's Justin from DAX Noob and wanted to go over two new DAX problems for this episode of DAXing with DAX Noob. The first one is by Kobisco. They post some interesting DAX problems periodically and thought it was interesting and wanted to kind of share how I went about solving it. So the challenge was your corporation sells products through different brands. Each product belongs to a product series. Each product can be sold by each brand, and therefore, each series might show through more than one brand. You want to count the number of series that show sales on each of a given selection of brands. You want to be free to select the brands. You want to calculate the following measures. So the number of shared series, so the number of series that have products sold by each of the brands that we've selected. And then those same series, we want to show a concatenated list of them. And then finally, we want the quantity sold shared series, which is for the selected brands of the series, how many products were actually sold. So the way that it should look at the end is we will have this brand name slicer where they're able to select one or more brands. Then the user should be able to see the measures here. So you can see selecting brand 1 and 2, there were 3 um, series. You can see the concatenated list and the quantities sold. And so this data isn't going to line up exactly with the data that we're working with, but this is just to show you what it looks like. So a couple of other people solved it in pretty interesting ways, and it mostly had to do with checking the number of products, the number of brands that were associated with the for each series, and then then getting the count of the selected brands and comparing counts of different products and product series and brands. But I wanted to solve it a different way using kind of set functions. So if we go to the model, the way that the model is set up is you have 3 tables. You have a products table with the ID, name, and series. You have a brand table with the ID and name. And then you have your sales that has the brand ID, product ID, and the quantity for each sale. And so if we go to our visualization, we can start to create a measure. So let me get actually the name of that first measure that we'll need to create. So number of shared series. So we create a new measure. So let's think about like what we might want to do. So when I look at a problem like this, immediately what comes to mind is, well, we're using the same underlying um, kind of like functionality in the sense of it all has to do with this list of valid series, because we can count that list of valid series and get one measure answer. We can concatenate that list of valid series and get the second measure. And then for the third one, as long as we can get the sum of quantity, um, but where the filter context is our selected brands and then that list of valid series. And so if we can come up with a method of getting a list of valid series, we can then, I think the rest of the measures should be just variations off of a single kind of structure. And typically, what we would do in this situation is, again, like we need to determine it's going to be influenced by the user selection. So let's start off with that. So the way to capture a user selection from a slicer, if you want all of the values that they've selected, you can use the values function. So let me do selected brands, the values of the column that is in our slicer, or some other column that we want to capture the values for. And so, so while they have the brand name in the slicer, I'm going to use the brand ID because it typically, I mean, it's the key. I know that the key is going to be in our fact table. So if I can use a key, I will try to do that. You can also capture user selection using selected value. That will make sure that capture the user selection if they have only one value selected. And if they don't, you can give it some alternate result, or you can use something like max, min, some other aggregate function. So here we are capturing the user's brand. And so now, again, like, what do we want to do? We want to get a list of valid series. And so again, like as I'm starting to build up DAX measures, um, a list of valid series makes me think of, right, well, I just need a list, and then I need to filter that list. So that's what we'll start off with. So I'm going to say valid series. So now I'm going to get the values of the series. And so how can we filter this list of values? Well, there's two main ways that you can start to filter a table. It's either calculate table or filter. And I'm going to start off with filter, because I have a feeling that we might have to do some row by row evaluation. So what do we need to do to filter this series? And so again, I'm going to try to use some set functions. And what we can do is, all right, so if we know, we can get a list of all of the brands associated with each product as we're iterating over this list of series, um, or associated with that series, each of the brands associated with the series as we're iterating over that. If the list in our selection matches the list that was historically associated with the series, then we know that that's a valid record. So we can compare these two sets, or these two lists of brands, in order to filter down the series, and then use that series to do the rest of our calculation. And so in order to get the list of the historical um, brand IDs that are associated with the series, we can again get if we're working with kind of like a list of values, we can use values. And in this situation, brand ID we can get from the sales table. And again, this is one of the reasons why I like to use the IDs, is now that we're starting to compare selections from the dimension and then values from a fact table. Since the brand ID is in both tables, it'll be very easy to compare them without having to worry about propagating filters different ways. Right now, this actually won't work, because there's nothing in this statement as is that says, hey, I want to get the list of brand IDs associated with the current product that I'm iterating over. There's no filter coming from product series in this situation, where um, coming from the specific iteration. So one way to do that is you can use context transition as you're used to change the row context into the filter context. So you would do that by wrapping your table expression in a calculate table, or use your scalar expression with a calculate. So since we're working with the table, the values function would do calculate table. And so now this would give us the list of brands associated with the current product series that we're iterating over. One of the issues that we have is we don't want these brand IDs to be affected by the selected values from our slicer. So what we can do in order to get rid of that selection temporarily is to use we can use an all function, say all brands, to remove that filter. Or I like to use, in this situation, the remove filters function, because it's a little bit more explicit about what is happening and easier to read. So now that we have this list of brand IDs associated with a product series, we can now think about, like, how can we use these set functions. So if we have our list of brands from the selection, our list of brands associated with series, well, if all these brands are in this list of brand IDs, then we know that this is a valid record. So one way to do that is to use an accept function. And so this is going to give us all of the rows from the left table that are not in the right table. So let me do the selected brand. So what does this mean? So we want return the table of brand IDs from this table here that don't appear in this table. Well, if if the product series is a valid product series for our specification, we would expect to see this table being empty, right? Because let's say that there's like brands 1, 2, and 3 associated with both of these selections, and the historical selection here, and then what we've associated, and then we've selected in the slicer 1, 2, and 3, then it would be empty, and that's a good brand. So as we are iterating over the product series, we want to let's make sure that the a valid series, the expression evaluates to true. So when it's empty, that means it's a good series. There's a handy function that is empty. So once this whole table expression here is empty, this expression will evaluate to true, which marks this product series as valid. So now I can just close off this filter statement here, and we can do our calculation. And so our first calculation is just the number of shared series. So let's call this calc, and we'll do the count rows of the valid series. And I saw this on the video of like what the answer result should look like, that if one brand is selected, that they don't want any result to show. And so for our results, we can just add a conditional if statement at the top to say if count rows of our brands, or of our selected brands, we want to make sure that more than one brand is selected. If this is true, then return our calculation. And then finally, we'll return the results. And we will see if it works. Yep, so this is exactly what I expected with the current data that we have. And so as we click around, you'll see it showed me this number of shared series. And so right here we have brand 1, 4, and 5. And so between those 3 brands, they've only shared one series, which is PS3. So now that we have the pattern for this particular measure, we can create a new measure. We get the name of what it should be. It should be the list of shared series. And it's going to be pretty easy now because we can just reuse this list of valid series here. So our calculation, instead of being just the count rows of the valid series, we can concatenate that list. And so we're going to go iterate over that list. We're going to get the series. We want to that's the expression that we want to concatenate together. Let me see. I forget what the concatenation had to look like. Okay, it was with the forward slash. So our delimiter is going to be the forward slash here, and then we can order by the product series. Oops, forgot to add the closing parentheses. So I add that here. Then you can see we add that here. PS3 is that one shared series. But then if I unselect brand 5, we have our shared series here, 1, 2, 3. 1, 2, 3 is what we see in our total row. And finally, we can create one more measure. And it's going to follow the exact same pattern as before. So it's the quantity sold shared series. Quantity sold shared series. And again, instead of the count rows here, we want the sum of the quantity, but only associated with the series that we've selected. To calculate sum of quantity for a valid series, and then also the brand that we have in our selection will also apply in the filter context of this expression here. So I will click enter, add the quantity sold here, and again, this is the result I was expecting from doing it before. And that's how you can kind of find the one pattern and apply it to other all the measures using some set functions. Okay, so the second problem that we're going to take a look at is this one that was posted on Reddit. The user was requesting some help optimizing a measure. They said that they have a similar problem statement that was described in this days of supply quick measure that we'll take a look at that was posted on the Fabric community forum. They did say that their data set is huge, about 50 million rows, and so we are not, just being transparent, I didn't try to solve for that 50 million row size of a data set. Something like this, I really do think it should be changed in the back end, and the data should be structured a little bit differently to try to answer this problem. Um, but it was a fun pattern to try to optimize and see what can be improved. So if we take a look at that link, this is what the report looks like. And so you have weeks on, for each week, you have the inventory and the demand for that week. And then the measure that we'll try to optimize is this days of supply that shows, are given the inventory for the current week, how many days taking into account the demand for future weeks, could that supply satisfy, or could that the inventory satisfy? So here you can see it's for this 49,000 units of inventory, we can supply 45 days worth of demand, and so um, it's about a little bit less than 7 weeks of the demand can be satisfied. Um, so Greg Deckler is the one who originally posted this the solution and the pattern. And I'm not going to take a deep dive into what he's doing, but overall, um, the pattern is calculating the base number of days. And so this is going to be the number of full weeks that can be satisfied by the demand, that can be satisfied by the supply, excuse me, and then multiply the count of those weeks times 7, and then some algorithm to get the remaining demand that can be satisfied for the week right after um, the the last fully satisfied week, and getting that ratio of um, the demand that can be satisfied with the remaining supply. And again, this is I'm going to try to optimize this measure. It's not about calculate versus no calculate. Ultimately, it's just about finding the best query plan that can satisfy that can run like satisfy the requirements of the measure. And sometimes it works with a calculate pattern. Sometimes it works with a no calculate pattern. That's all about the query plan. And sometimes both patterns result in the same exact query plan. So let's take a look at the measure. Um, so yeah, I just downloaded the copy that was in the service of the PBIX, and so it seems to work. It's pretty snappy. Um, if I refresh, so turn on the performance analyzer, refresh the visuals, it runs in less than a third of a second. But the issue is when you start to increase the size of the data. So if we take a look here, right now there's only 28 records within the table. And so if I go to transform data, what we're going to do is I'm going to replace the data set with a table that's a little bit larger. So I have that in an Excel file. So I'll show you kind of how you can switch the data around without breaking the visuals. So if I'm connecting to the Excel file and I have the information saved in this table here. So I'm going to load that into Power Query. I'm going to detect the data types. And if we look here, the schema is the exact same that is in the current table. And so what I'm going to do is I'm going to go to the advanced editor for the new table that we've brought in. I'm just going to copy that code. I'm going to go to the main inventory table that we already had. I'm just going to replace that code, delete like our temporary table here. And then I'm going to load the data. And so you'll see, since we've done that, the visuals won't break. We're just kind of switching out the underlying data while keeping it pointed to the same table. So once that loads, you'll start to see the problem. So again, it's not a huge data set. It's only 1,500 records. The data is a little bit different um, than Greg's underlying table, but the pattern will be fine. I just used some more recent dates instead of the existing weeks. But if we look here, as of now, it's the measure is still loading. As you can see at the top left-hand corner of the visual that we're still rendering. And I haven't waited long enough for it to ever render. And so you can see that the current pattern isn't quite suited for data sets that start to grow in size. So let's think about how we might want to solve this problem a different way. So I'm going to actually remove that measure from the visual, and I'm going to go ahead and delete some of these other visuals because really I just want to optimize what we see in this table visual here. Okay, so I actually want to follow the same like end result that Greg had of trying to calculate the number of full weeks that can be satisfied completely by the current inventory. And then once we have that, we can get the next week's demand and get that ratio between the remaining inventory after the full weeks have been satisfied, and then do the ratio between that and the demand of the next week to get some number of partial days. So let's try to solve that. So thinking about like what pattern can we use? And so, well, really, in order to determine like how many weeks can be fully satisfied, we need to be able to get like the running total. For instance, let's say that we have this unit here of 40,000 on May 22nd. So we would want to be able to tell if I have a running total for the weeks after May 22nd, as we start to run up, when does that number positive? Because if the demand, when we compare that running total demand with the inventory, subtract that from the inventory, if that number is positive, then we know that the inventory has been able to satisfy that week and all the previous weeks. So let's kind of think through it, like how could we do that? So one, we could maybe capture the date of the current filter context, and then just look at iterate over the weeks over that. We could get maybe the running total up until the current week, and then the running total of um, every other week, and then just subtract them. But like let's start to work through this together. Okay, so I'm going to call this measure days of supply new. We increase the font some. And what we want to do is we will want to capture the selection of the current week. So select a week. There's a couple ways that you can capture the selection or capture the value of it within the filter context. You can use something like selected value. You can use values if it's a table of values. But oftentimes you want to use some type of aggregate function like min or max to capture that. So I will capture the week within the current filter context. Then I will want to capture the current inventory. Oops, not selected. Let me change this. I'll say current week and then current inventory. So I'll do the same thing, max of inventory. Right. And so again, one of the algorithms that we can do is if we capture the cumulative demand up until the current week, and then if we're just looking at future weeks, if we capture the cumulative demand up into that week, well, then we can subtract the future week's cumulative demand from the current week's cumulative demand, and then it will give us that cumulative demand for the remaining part that we care about. So to start off, we'll want to capture the current cumulative demand. And to do that, we can do calculate the sum of that demand, and we'll want to update the filter context to look at the current week going all the way back to the beginning of the data set. So we will say where the week is less than or equal to our current week. You can also, depending on how you're applying other filters, you might want to remove filters from other things. But so just to be safe right now, I want to remove filters from the rest of the table. Again, this might not be necessary. It just depends on how you envision users applying other slicers. Over here, this now should give us the cumulative demand for each week. So if I put this into the visual, you can see for the first week, we have the current. It just matches the demand, but then every other week it's adding the demand for every prior week. So now what we can do is go back to our measure. We need to, for each of the future weeks, we want to determine like which filter those future weeks down to be the valid or the fully satisfied weeks. So one, we need some variable that's going to give us just what are those future weeks. So I will call this variable future weeks. Again, you can do this several different ways. I'm just going to use a filter statement where we're going to take all of the weeks, and then we want to filter these weeks to be where the week is greater than our current week. So now we have a kind of a table of weeks or a list of weeks that we are our kind of target to check to see, like, hey, can this week be satisfied by the demand? And so what we can do is, well, we need to get that cumulative demand for each of these weeks. And in order to do that, now we can maybe say, I'll say future weeks stats. And so for each of these future weeks, I'm going to add a column. And then I'm going to call this maybe future cumulative demand. And we can do the same thing that we just did above, but now instead of having the filter context be from the week that they're on in a given cell, we can update the filter context by using this calculate statement. Calculate will transform the filter context of the row that we're iterating over. So here we're iterating over this list of weeks. And so we can transform the row context into the filter context. But we do need to make a little bit of a change. So we don't want, as we are calculating the demand here, or the cumulative demand to be based off of the current week, which is captured as we are looking at the current filter context. We want to take the week of the row that we're iterating over. So you can do that a couple ways. You can use the earlier function here, and this will capture the filter context of week for the closest filter context that we are looking at. So here it would be the filter context of the future weeks. But I prefer to use variables instead of this earlier function, just because we have variables now, and it's a little bit, the earlier function isn't used as much, so it can be confusing to other users. So I'm going to create a variable and say local week, and then I'm just going to set a reference to the week that we're iterating over. And then I will say local cumulative demand is going to be equal to, so this same expression, instead of earlier, we're going to just refer to the local week here. And then we can return the local cumulative demand. Great. So now we have the local demand. And so what did we say? We said that we want to find the difference between the local demand and then the current demand or cumulative demand that we're on for a given week. And since we've already filtered these future weeks to being weeks in the future, um, if we can take the difference and then we can compare this difference in demand to our current inventory. So let's start to build that out. So I will say, I'll say future, maybe partial cumulative demand can be equal to the local cumulative demand and subtract out our current cumulative demand. So this is just going to be that remaining part. So if we look at the cumulative demand of May 29th, and then we want to see how many weeks in the future are positive. So we would be taking, if we're looking at June 19th, we would be looking at the demand from from June 5th all the way up to June 19th. So go back to our measure. So now we just need to compare this expression with our current demand. So we'll say remaining inventory. Just remaining inventory is going to be our current inventory. Subtract this future partial cumulative demand. And so now if we actually return this expression, we now have a table that gives us for the future weeks how much of the remaining inventory is there after that the rest of that future cumulative demand is removed. And then to get the base number of weeks, we can just filter. We can say valid base weeks. We want to then filter this list of weeks here, so filter, where this future cumulative demand, or actually let me update this variable name here to be, we'll call it the remaining inventory, where this remaining inventory is greater than 0. So if it's positive, we know that the current inventory can satisfy that future demand. And then our result is going to be the count rows of these valid base weeks times 7, because there's 7 days in a week. So now if we return this, commit the changes, and we look here. Okay, that looks funky. So let me just make sure that we are doing this right. Okay, so we are filtering this here. Okay, so I just had this this expression wrong here, because we don't. This would be the current week and all past weeks. We just want the future weeks. So again, testing your DAXs is important, and then setting these variables so that you can take a look at things step by step is important as well. So if I commit this, okay, this is more what I was expecting. So we can see here that this inventory of 40,000 can be satisfied with completely with six weeks. Looking at the cumulative demand from May 19th to May 29th going forward. And so that you can see all of these are divisible by 7 because they're all it's just representing the base number of weeks times 7. So now we need to figure out how to get the last remaining part. We saw that even now, if I refresh the visual again, it will take a couple seconds for this to render, but much faster than it not being able to render at all. So how can we do this? So we could do it a couple different ways. One, we could maybe determine the greatest week from these valid weeks and then add 7 to that and then get the demand now that we have the new week for that. Again, like what we're trying to do is for this date, it says that we can go 6 weeks and fully satisfy the demand. So 1, 2, 3, 4, 5, 6. If we now then know that the last week is June 26th, we can just get the demand for the next week. So add 7 to June 26th will give us July 3rd, and we can get the demand for July 3rd, and then do our ratio with the remaining inventory. So that's one way to do it. But again, what we want to try to avoid is continually looping over the same data. And since we're already iterating over the weeks here, I think that we can just capture that selection a different way, capture that demand a different way. So while we're already iterating over this, we could capture the future demand while we're doing this. So how can we do this? Well, just if we had a different variable and we said next week demand, well, we know the local week that we're currently iterating over. And so we could capture the demand by doing something like the sum of our demand, where the week is equal to this local week that we're iterating over plus 7. And we'll remove any filters on the inventory table just to make sure no other filters are affecting the calculation. And so now we could then return this. So this next week demand. Well, the issue that we have here is that they with add columns, we can only add one column per like we can return multiple expressions, but we'd have to add another column where we also want to add the next week's demand. But then if we do that, one of the issues is like we'll have to repeat the variable again. So as an example, let me add another expression. We'll say next week demand here. I'll have to capture this local week again as a variable. Then I can do this next week demand here, and then return next week demand. And then I can just restore this original calculation where we're returning the remaining inventory. It works, but I don't like the fact that we have to kind of declare this variable twice, and sometimes there's a lot more variables that you needed to share between the columns, the multiple columns that you're returning. So an alternate way of doing this is you can actually use the generate function, and instead of returning columns, what you do is you have some table that you want to, so some table expression that's evaluated row by row, and then you evaluate a second table expression within the context of the first table expression, and then will create this like cross join where the filter context is propagated between them, and so what we can do now is we just need to return some table that includes both of the columns that we want to return. So let me do this. So we have our existing code, we have our remaining inventory at our next week demand, and then our result can just be a row function, which returns a table, and then we can return the two columns that we care about, and then it can and then also share this local the local week variable. So we want to return the remaining inventory, and we want to return this next week demand. Okay. And then return this result here. So this base calculation remains the same. So we'll call this base days. So how do we calculate the partial days? Well, we need to be able to access add this @ symbol here. We need to be able to then to access this next week demand for that final week, the highest week. So we can get the last, or I'll just say final base week. It's going to be equal to the top n. So the first, like the top one row of our valid base weeks, and our order by expression will be the weeks in descending. So we're going to sort these weeks by week, and then just get the max week, and then once we have that, we can get our next week demand. We can get somehow now, like, because that returns the entire table of the week in those two columns that we cared about. We really want to just access this next week demand, and so we just need some aggregate function to access that. So I'm going to use the max function, and then we can access the next week demand, and then we'll have one final variable that's remaining days. And so now that we have these remaining days, we can calculate somehow get the remaining inventory, and so this remaining inventory here, and subtract out the next week demand. So if you think about it though, we would need to do something similar to this pattern here in order to access this remaining inventory number. So instead of doing it like this, where after we've kind of computed these week stats, and then getting both pieces that we need, and then subtract, like doing the calculation, why don't we just return the remaining days instead of the next week demand? So let's try that. So what we need to do is we can just return the remaining days here. So go ahead and calculate it for every single row as if the condition were true. So I'll say remaining days. We can then divide our remaining inventory by our next week demand. And then we can round this expression here to the nearest whole number, because you can't have in our case, we wouldn't want partial days. So now instead, we're going to return this remaining days here. And since we're only, again, filtering for valid base weeks that are in the future, we can access, again, we still want to get that final base week. But then for the final base week, we don't want to just get the next week demand. We want to return the remaining days here. So now I can call this remaining days. And then for our final result, we'll simply add the base days with our remaining days and get this result here. Should just take a second if I did it right. All right, sweet. So it's about the, no, actually, let me refresh the visual just to see how long it takes. So it's a little bit, I mean, it's definitely slower than before. So this time it took about 8 seconds, but you can see now these numbers are not just divisible by 7. We have the full weeks times 7 plus those base weeks. And so it works. Again, like this is maybe one pattern to do it. There are a bunch of different ways to achieve the same end result. I was actually playing around with additional ways to do it, experiment with different patterns. Again, like trying to look for saving the number of scans, again, looking at DAX Studio to see how the query plan is set up. Was able to find one additional pattern that's just a little bit different than we had. That is faster. So let me just copy and paste that in here. Um, Overall, it's relatively similar. We're doing the same capturing of the current week, current inventory, and the cumulative to date. But instead of doing all of those calculations within one generate function, I updated it to just return the cumulative demand of the local table for every single week, and not just the future weeks. And then the demand and the next week demand for every single week. So we'll go ahead and pre-calculate that for every week, even the past weeks. And then filter out to just the future weeks after we've already pre-calculated all the statistics, and then add 2 additional columns, the remaining inventory, the extra days, and then everything is pretty much the same. And when we update it to this pattern, just kind of moving around how everything is, where the calculations are happening, it cuts the speed of the calculation in half. So again, like I wouldn't have maybe known that or thought through that the first time that I was writing the measure, but iterating a couple times, experimenting with different patterns, you might find one that's even better.